Welcome to STARS Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Welcome to STARS Launch Pod, Space, Technology, and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise, and it's an honor to have with us on the podcast today, Dr. Dan Britt, Professor of Planetary Sciences at UCF. Hi, and welcome to the podcast.
Well, thanks very much for having me.
Now, I understand you've had a role in several NASA missions, so I'd like to dive into that. I'd like to know what your focus is at UCF and what you're doing to further the space industry.
Well, that's a pretty broad question. For NASA missions, I've been lucky to be on 4 of them. Mars Pathfinder, Deep Space One, which went to Comet, New Horizons, which went by Pluto and then on to a hyperbelt object. And now I'm on the Lucy mission, which is going to 5 Trojan asteroids, which are in the orbit of Jupiter. So that's been a huge honor to be able to participate in that. That's really what my career goal was to be on a NASA mission. And now I've been on 4. So I'm quite pleased with
That's
myself.
exciting.
Yeah.
You should be. What's your main focus?
Well,
on
my
these
main
missions?
focus is the surfaces of airless bodies, because part of the issue is that we live in the most unusual place in the solar system. No place else has liquid water and oxygen. And so we are used to an environment that doesn't exist anyplace else. And so quite often scientists and engineers take this attitude that, we understand how things work here, they should work the same way elsewhere. But the problem is those are truly alien environments. And you have to actually get over the fact that what you grew up with, what you experienced, is not what's going to happen elsewhere. And that's hard for a lot of people.
I mean, especially if we want to eventually live there someday.
Oh, yeah.
I mean,
We live in this oxygen poisoned, water saturated environment. And that's not going to happen on the moon. It's not going to happen on Mars.
so we're looking for ways to, I don't know, I guess, adjust and be able to adapt, I guess, in some way.
Yeah. And that's what I try to do, is to get people to test in a more realistic environment. For instance, my thing right now is their surface and trying to simulate the regolith that you find on lunar surfaces.
So how do you see our future for that? I know they want to be established there on the moon, and we're headed back, at least around there.
Well, I think that this is not a tough problem. You just have to be realistic about it. And one of the problems that we have conceptually is that you look at almost all the artist conceptions of the lunar surface that come out of not just NASA, but ESA and the private companies. And they're just complete delusions. They think that they're landing on billiard table flat surfaces with nice firm areas to land. And the actual surface is saturated craters, and it's covered with dust. And you're going to land in a dust. And some of the private landers that have failed are blaming the dust. Well, come on. Dust has been there for 4 billion years. It's not like this should be a surprise. We've been there a bunch of times.
Yeah.
You read the accounts of the Apollo astronauts that actually landed in the dust, and it's terrifying. And so blaming the dust is like blaming the thunderstorm for happening in the afternoon.
Right.
But
isn't
I'm in
that-
Florida, that happens every afternoon in the summer.
Isn't the dust something that you could adapt to, like as far as like waiting for it to settle, and you have to account for that, right?
Well, yeah. But remember that when you're landing, it's not like you're floating around. You have to expend fuel. You have to have the necessary, what they call is control authority. You have to be able to control your spacecraft to a high degree of precision. That's not that hard. It just requires a certain level of engineering and planning. And sometimes people try to cut corners. And when you cut corners and you don't adapt to the environment that you're in, you will fail and fail catastrophic.
So, what has been one of your biggest aha moments on your journey?
I've had a few, but mostly it's finding that there are fairly simple measurements and studies that need to be done that just haven't been done. And so I was able to find niches. When you're coming out of graduate school, there's always a tendency to think, well, everything's been done. What am I going to actually do? And it turns out that once you have a little bit of experience, you find out that, well, actually not that much is done. There's a lot that can be improved. And so my aha moments have been realizing that, oh, well, you actually need to understand asteroids. You actually need to thoroughly study meteorites. So that was something that hadn't been done from the point of view that I attacked it from. Same thing with the surfaces of the moon. Again, this is something that had been done a bit during Apollo, but a lot of things have just not been done. And so there's a lot more that can be done. And that's what I'm looking for.
Dr. Britt, when you're studying meteorites and you're looking at, I guess, maybe the composition, what kind of things can you learn from it? How does that
Well,
help you?
what I was working on was the density and porosity of meteorites, and that relates to how the structure of asteroids, how they're put together. And so I had a graduate student who was starting with me, and he said, well, aren't these measurements a little bit like stamp collecting? What are we going to discover? And I said, well, I don't know. That's why we do it. I don't know what we're going to discover, but I will guarantee that you will discover something that will piss people off who thought they knew what they were talking about. And he actually discovered two things rather than just one, and annoyed people. But what he did was illuminate some reality that people had just not understood.
Oh, what kind of challenges do you face and how do you overcome them? What has been one of your biggest challenges?
Oh, I think the biggest challenge is people deluding themselves, ignoring reality, assuming that a serious problem will go away just because it's not something that fits into their schedule. You see this a lot with people who are designing landing systems. That's a continuing problem because the failure rate on the small landers that the U.S. is sending is about 50%. That should tell you something. And apparently the message has not gotten through.
There's some room for growth in the engineering area, I guess.
Well, there's room for growth. You look back at Apollo. Half the Apollo landings had problems with not landing level. So one of them actually was tipped very close to their failure point. And this tipping problem is a serious one that has been largely ignored.
Is that something that AI may come into play and be able to assist us in that area? Because I mean, so many people are, jumping on the AI stuff now.
The short answer is no. The long answer is no. Your problem is getting information. AI needs information.
Right.
If you're landing in a dust cloud, what you have is poor information.
Okay.
Or no information. So AI is not going to help you there. What you need to do is create a system where you land with some degree of certainty. And now that's not impossible. There are ways to do this. It just requires a little bit of effort. I mean,
So
people have operated helicopters in Iraq and Afghanistan for decades. You ask a helicopter pilot, how do you land in a dusty terrain? And there are ways of doing that. We can adapt.
So don't we need to get there and build some sort of landing pad that is a permanent place?
It's probably the ultimate answer. But getting there prior to landing pads, you're going to have to figure out how to deal with the dust. And your problem is that you're getting this cloud of opaque charged particles. And you're not going to see through it optically. You're not going to see through it with radar. You're not going to see through it with LiDAR because it's a cloud of opaque particles. It's not going to go away.
I mean, my brain says, well, can't we just hose it down first?
Yeah,
know?
well, water saturated, oxygen poisoned. No, we're not. You're going to land in the dust. The way we did it with Apollo was we chose the 6 best test pilots in the world. And we trained the hell out of them. And they still had problems. Half of them had problems. Now, the other thing, I will say something fairly unscientific right now. Back then, the attrition rate on test pilots, fatal attrition rate, was huge. And so not only did you, in a very Darwinian fashion, choose the very best, you also chose the very luckiest. And lucky is one of these things that you can't quantify, but it seems to work for some people. So, we end up choosing not only really good people, but also really lucky people. And so we were really, really lucky in the fall. We can't depend on that. We need to find something besides luck. And it's fundamentally not that hard. You just have to think through the problem and develop some technology.
You have any advice you'd like to share with our listeners?
Well, the space science stuff is quite interesting. It's a lot of fun to do. I started out and changed my career rather abruptly because I thought it would be interesting to do. Well, it's right. It has been interesting to do.
Well, how did you start out? What did you start out and then
Oh, I
changed?
studied economics in college. I worked on the admin side in Bowie for several years and just got bored with it. So in my 30s, I went back to school and got a PhD in geology in order to get involved in this. And fundamentally, you can't be a dummy, but you don't have to be the smartest guy in the world to make basic contributions to this field. So just go for it. If you're looking for security and you always want to be right, you should find another field because you are wrong all the time and you get no security. The problem is that your major funding is from the federal government, and the federal government changes their whims on a dime.
True. A lot of this space exploration and, as far as the future goes, it's becoming more and more something that the general public is involved in, like business, like it's not just governments anymore. And I think that's kind of exciting.
It is, and it produces a lot of new opportunities. SpaceX has revolutionized the opportunities for space travel. And so I'm quite optimistic things are moving forward. The problem is that you're getting a lot of people who don't know what they're doing involved in this. And there is large room for what I do, which is I educate. And so the issue is whether people know they need to be educated.
What are your thoughts about, and what are you wanting to learn with Artemis coming up?
Well, my thoughts are that it's a long time since we've been back to the moon. And what we're doing with Artemis is trying to do it in a sustained fashion to systematically explore rather than being scientific tourists. And there's a lot of potential there. It's just that what Artemis is finding is that they have this long list of unknowns that they would like to know before they go. And that's going to be hard to do.
Before we wrap up, I just want to ask you if you have a passion project, past or present, that you'd like to talk about.
Oh, I get lots of passion projects. My current passion project is kind of trivial, which is to convince the space agencies and private companies to actually do their artist conceptions in a more realistic fashion so that they don't try to fool us and fool themselves as to what the moon is like. And so I don't miss many opportunities to remind people that, wow, the picture that you're showing is not anywhere close to where you're going to operate and how you're going to operate. You're just fooling yourself. And usually the excuse is, well, we don't control the artist much. You must pay them. They do what you tell them. Just tell them more realistic stuff. That's my pet peeve. My passion project is to understand how to operate on moons and asteroids. And I think that eventually we'll be able to get resources from those two sources. There's a lot of work that needs to be done to get there, but it's certainly not beyond the realm of possibility that we'll be seeing asteroid mining in the next 10 years.
And speaking of asteroids, there's one out there called the Dan Britt, right?
Yeah, it's a long way away, though.
Do you ever check on yourself and like, how's it flying?
Occasionally, yeah. I was very lucky to get an asteroid named after me. So I
How
feel
did that
very
happen?
honored.
How did that come about?
Oh, if you work in the field of astronomy and meteoritics, studying meteorites, you're generally poorly paid and disrespected. And so one of the perks is you can have a piece of geography named after you and you don't have to be dead. If you get a mountain named after you or a crater on the moon or something, the requirement is that you're dead. And so,
Okay, that's
you feel a little less honored that way.
so. Is there an opportunity for us to see Dan Britt?
Oh, sure. But you need a big telescope.
Okay.
You should spend some time on a 1-meter telescope. You can see it just fine.
So
And-
what does asteroid Dan Britt look like?
Oh, well,
general.
it's fairly nondescript.
Oh, come on. It's
not
probably
that interesting.
fabulous.
There are scientifically interesting meteorites and asteroids, and there are ones that are not, the ones we know pretty much everything we need to know about. The Dan Britt one does not have that many mysteries.
Well,
So,
in all
but
in
that's
all, we have
okay, it's like 30 kilometers across,
wow.
it's a
Okay.
mountain
All
floating
right.
in space. So, hey, that's enough.
Yeah. Well, we have a lot to learn about what you're doing at UCF. Anything you'd like to talk about there?
Well, right now, what we're doing at UCF is we've built facilities to test in regular simulation. That is stuff that simulates the material that you'll find on the surface of the South Pole. And we do things like we host the NASA Lunabotics competition, which is 50 university teams competing to build rovers that can excavate and traverse that terrain. You work with private companies testing various types of hardware. We worked with NASA doing various projects, regolith related, on how you land on regolith and what happens when you do. And so this is what keeps us busy. There's a lot to learn there. The more you learn, the more you realistically test, the less you're likely to fail. And so that's what we're trying to do, is to help people not fail.
I'm glad we have a professor like you at the helm teaching students and learning, and you being part of the NASA program. I think we have an exciting future.
Well, it is. It's been exciting, and I've had a wonderful time doing this. I think there's a lot left to be done. So people that are getting into the field, don't despair. There's vast amounts. There's a long list of unknowns, and it take serious work to close those out. And the problem, of course, is that once you do that, you ask more questions and you discover more unknowns.
Dr. Dan Britt, Professor of Planetary Sciences at UCF, thank you so much for joining us today on the podcast. We love hearing your story and excited about the new discoveries to come.
Well, I'm happy to be here, and I'm looking forward to the future.
Make sure you join us where we connect, collaborate, and accelerate. And if you enjoyed this episode, leave us a review and subscribe. Until next time, keep looking up. Thank you, Dr. Britt.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. Stars Launch Pod, propelling us forward, one launch at a time.